Hello there to our Friday asynchronous class. On Wednesday, I was talking or introducing you to all the ideas of algebra. So we have the idea of a variable, and often a variable might be something like x, or maybe y, or maybe C for Celsius, or maybe m for mass. So these are variables. It's like a symbol that represents something. And then another word we had from Wednesday's class was coefficient. So this is usually a number like 5 or -2 or 1. These represent the quantity of something. So for example, when we talk about terms, I can say 5x because I have 5 of whatever x happens to be, or maybe -2 times y. So the 5 is the coefficient, and the x is the variable in this case. Okay, so this is just going back to what we did Wednesday, and bringing it all together. And today we're going to do some solving. But just to make note that we need to keep in mind things like terms, and also means not like terms or unlike terms. Sometimes we're going to collect like terms or combine like terms. And then we have this idea of what's called the distributive property, which is kind of handy. A little review on that would be something like if I have 5 and then inside a bracket I have 2x plus 3, then the distributive property is that the 5 gets multiplied by each element of the bracket. We know that because this 5 is written beside the bracket. Implied here is that we're talking about 5 of everything in the bracket. Okay, so what that means is we have 5 times 2x, so that's 10x, and 5 times 3, so plus 15. Okay, so let's just bringing us up to date with what we did on Wednesday a little bit. Okay, so today we're looking at some translating from English to algebraic expressions, and then the big idea for today's lesson is solving equations. So we're going to do quite a few examples of that. Okay, let's talk about translating English to algebraic. For example, if I want to do 5 more than some number, that would be some number being x and 5 more. So we could go x plus 5. Okay, that's one example. Another example would be half of a number. Well, we could write that like this, half of a number. Let's use the letter n to represent a number. Or we could write n divided by 2. We've talked before about the same, dividing by 2 and multiplying by a half are the same thing. These are examples from slide number 9 from your PowerPoint. So I'm just kind of making some notes as we go, looking at the PowerPoint as well. 5 more than 3 times some number. I'm going to write that one down in English. 5 more than 3 times a number. That's the English. And that we can translate that. We know that we've got 3 times a number, so that's 3 times a number, and 5 more, so plus 5. Pretty easy peasy. Next example on the slide is 6 less than the product of 2 numbers. let me write that down, 6 less than the product of two numbers. So let's just break that apart a little bit, because the product of two numbers, we could write that as maybe one number is m and one number is n. So if you write m and n side by side, that's basically saying a product. Product means multiply, and mn is the product. And we need to make 6 less than that. So I'm just going to rewrite that. Here we go. So on eraser here. Okay. Oh, I'm just getting the hang of this here. Here we go. So we're going to have mn. That's a product of two numbers, and 6 less than that. So minus 6, because when you subtract 6 from something, you get 6 less. All right? And then the last example from this slide, it's 76%. 76% of some number. So that translates as 76% of some number. Let's say x. I could write that also as 0.76, because 76%, remember, that's 76 out of 100, which is going to translate to 0.76 times x. And in this case, just going back to some of the vocabulary that we have, the 0.76, that's called the coefficient. Okay, so, and the x, that is the variable. So we've got this x, we're calling it a variable, and it is representing some number. So that's the idea here. Okay? So that's just doing a little bit of English into algebraic expressions, and we'll practice that as we go. I want to talk a little bit about solving equations now. And maybe you've had some experience with this before, but just want to kind of do a few ideas that are a little bit visual. Maybe they'll help. Today in Wednesday's class, I had those little puzzles, and those puzzles kind of gave us a chance to, or a reminder that when we're solving equations, we're trying to also balance equations. So like a super easy equation is x equals 5. And just to talk about that a little bit, it's kind of like, okay, suppose I have a bar, which I'm going to say its value is x, and it's exactly equal to 5. So that's kind of x equals 5. So that's kind of obvious, but I'm going to make something a little tougher here. Like, what about 2x plus 5 equals, let's say, 11? So we're going to solve this algebraically, but I think this is kind of cool. If I make 2x like this and a 5, these are kind of random lengths, but notice that my two x's, okay, this x and this x, they're both the same size and the same length and so on, and those have to be equal to 11. So in this example, 2x plus 5 equals 11, when I write the two equations as bars, just trying to give you a visualization, notice if I cut this into 5 and 6, you see on here this section here, I've got 5 equals 5. That's kind of obvious. But then on the left, this is kind of nice. This is 2x is equal to 6. And when we look at that visually, we can see that 1x is going to equal 3. So sometimes the solving equations can be done with a little picture, or even just, sometimes they will just come to you as a, well, I know what the answer is. And that's good. That's always acceptable to write down the answer if you can just do it in your head. What about something like 4x plus 7 is equal to 2x plus 17? Okay. Now we're getting a little bit bigger equations here, but I can still think about it with these boxes. I kind of like this view of things. I've got 4x's. Let's go like something like 1, 2, 3, 4. So this is x. It's unknown. It's just a box. There's going to be a number in there. And then 7. Okay, so I've got 4x plus 7. And right below it, I'm going to put 2x. So there's 2x, 1x. And then I've got 17 here. Okay? So this is visually, it's kind of neat, because this x and this x, along with the second pair, these guys, I can kind of just forget about them. And now I've got an easy question, sort of like example number 2. If I take x plus 7, it's now equal to 17. I'm going to cut this one, and this is 7, and this has to be 10. Isn't that nice? The 7 and the 7, they're the same. That's kind of obvious, so we don't have to think about them anymore. And we're left with 2 x's and 10. 2x is equal to 10. So that means 1x has to be 5, because 5 plus 5 is 10. I'm just showing you some equation solving, but using a method that maybe you haven't seen before, just for fun. What the heck? Just something we talked about on Wednesday is the idea of substitution, and I feel like x equals 5 on this last one. We can actually check to see if our 5 is a good answer. And so I could say, well, the left side, here's the equal sign, the left side is 4 times 5 plus 7, and that equals 20 plus 7, which is 27. Okay, and then the right side of the equation, that's over here, is 2x. X is 5 still, so 2 times 5 plus 17. That's 10 plus 17. Also equals 27. So the left side is equal to the right side. So that's a way of just checking to see if the answer is in fact correct. And so x equals 5, we're good to go. All right. I'm going to drop in a question here. Example number 4. And example number 4 is going to have a fraction in it. Okay, quarter x plus 3 equals 1/3 x plus 7. Okay, now we could still use our little boxes and rectangles and everything else if we wanted to. But sometimes when you get a fraction, a nice strategy is to multiply everything by the lowest common denominator of 4 and 3, which is equal to 12. Okay, so let's look and see what happens when we multiply everything by 12. We do that. So I'm just going to go 12 times 1/4 x plus 12 times 3 equals 12 times 1/3 x plus 12 times 7. Now it looks like it's getting more complicated, but the nice thing here is that 12 times 1 divided by 4, that equals 3x. So I can go, and now 12 times 3 is 36. And then the next fraction, 12 times 1/3, that's 12 times 1 divided by 3, that's 4x. And finally, 12 times 7 is 84. Okay, now we can go back to our rectangles if you like. But something I want to observe, this is moving away from the rectangles a little bit, to observe here, is that the left side of the equation has 3x and the right side has 4x. And when you think about that, if I subtract 3x from both sides of the equation, okay, this a little underline maybe makes it a bit confusing. This is the idea of keeping an equal sign, honoring the equal sign. So when we say that the left side is equal to the right side, then if we take 3x away from both, we're good. And so 3x minus 3x, these cancel out. And on the right-hand side of the equation, we end up with 4x take away 3x, which is 1x. And this little activity that we just did, we're simplifying algebraic expressions, right? 4 take away 3, you've got 4 of an object, 4 of x, and we take away 3 of the same x, and we end up with 1 of them. Okay, I'm going to write this 36 here and this plus 84. And this is kind of interesting. We're taking a number x and we're going to add a pretty big number and end up with a smaller number. So probably the answer is going to be negative. And we'll see, in fact, that that's true, because what I'm going to do here is take away 84 from both sides of the equation. Okay, and the reason being that what I've done is I've isolated the x. The plus 84 and the minus 84 they're eliminated. And so this equation is x on the right side, no problem, and on the left side, 36 take away 84. Now you might jump onto a calculator, I don't know, but just a reminder, here's 36 on the number line, and we're going 84 units to the left. So it's way down in the negatives. How far down? It's negative 48. And that is the answer to that equation. That was the example number 4 had fractions. So when you've got an equation that has fractions, good strategy is to multiply everything by something. The lowest common denominator is ideal. And when you do that, you can get rid of all of the fractions. And that's often a much nicer strategy than trying to add or subtract fractions. I'm going to do one more example here and then take a pause in the video. So this is from one of your slides in the on the PowerPoint. It's slide 14, and the example is 2 bracket 3x minus 4. So we're going to have some distributive property there, plus 5x. Oh no, never. This is just simplifying. It's not solving an equation. So let me just back up on that. Forget it. Sorry about that. I advanced my slides, but not far enough. Okay. One moment. So I'm going down to some... Okay. This one is on slide 26. Okay, and the example is 5 bracket t plus 3 plus 9 equals 3 bracket t minus 2 plus 6. And this is an equation, and I know it's an equation because it has an equal sign. So that means it's an equation. Okay. All right, so first we're going to have a look. We've got 5 and we've got t plus 3. So this, our distributive property says that we're going to multiply that out. 5t plus 15 plus 9 equals 3t minus 6 and then plus 6. So in this equation, we've gotten rid of all the brackets. That's a good first strategy. Now I notice here that minus 6 plus 6 can be eliminated, and we can further simplify this by saying 5t plus, and we can take the 15 and the 9 and put them together, and that would be plus 24 equals 3t. Okay? So in this one now, we look at the equation, and you've got on the left side we have 5t, and on the right side we have 3t. We can do a few different things, but I've got 24 here, and I've also got the 5t and a 3t on the right. Let's move the 5t over to the right hand side, and the way we would do that is using the inverse of 5t would be minus 5t. Okay, and when we do that to both sides of the equation, we are able to move things around. So I'm down to 24 equals 3t minus 5t. So that'd be negative 2t. Okay? And that's no problem. It means that minus 2 times something, the t is a variable, negative 2 times something equals 24. And when we're solving equations, another sort of general idea is to do the inverse. So instead of minus 2 times t, we can divide by minus t, or minus 2, excuse me. Okay, so when we do that, the nice feature is the minus 2's disappear, and we're left with, on the right side, the letter t, and on the left side, 24 divided by minus 2, so minus 12. And I'm going to put a box around that. And that is the answer to this problem. Let's do a check, just because it's always good to check our answers. And so I'm going to put my check up here. Left side equals, and I've got 5 bracket. So this is going to be negative 12 plus 3 plus 9. Okay, and that's I'm going to do brackets first. So 5 times negative 12 plus 3, that's negative 9, plus 9. And that's 5 times negative 9 is negative 45 plus 9. And that's going to be negative 36. Okay? Because if you think about a number line and you think of where minus 45 is, here's 0, and we're minus 45 plus 9, we end up in this area, minus 36. Okay, let's look at the right side. I'm sure it's going to work, but this is just showing how confident we are. Negative 12 minus 2 plus 6. Notice I'm doing the left side, and then I did the right side. So this time I've got 3, and in the brackets I got minus 14 plus 6. And that would be negative 42 plus 6, and that equals negative 36 also, which equals the left side. So we know we got this one right. All right. Today, Dr. Ramirez has 26 patients in a day. They saw 4 more patients in the afternoon than the morning. And then the question, how many patients in the morning? And part B, how many patients in the afternoon? So if we think about that, we know we have 26 patients altogether. Okay? And how many in the morning? We don't know. Let's say that's X. That's going to stand for the number of patients in the morning. And it says in the question, they saw 4 more patients in the afternoon than the morning. So the afternoon is 4 more than the morning. So if the morning is X, the afternoon is X plus 4. And we know the total is 26. So we can put a plus sign here and an equals here, because we're going to put the morning plus the afternoon together, and that's going to give us a total of 26. And now I'm going to collect like terms. So X plus X is 2X plus 4 equals 26. Now this equation is much easier to solve than the last few that we did. But anyway, let's just carry on here. I'm going to make the 4 go away from both sides. So that leaves me with 2x equals 22. And therefore, x equals 11. Okay? Just for fun, I'm going to get some fancy colors here. Let's go with a pink here. Nice. That last equation, 2x plus 4, here's kind of like this. You know, we had an x, and a 4. And that has to equal 26. You know, so just as we did before, if we just chop the 4 off, this is 4 here, this has to be 22 over here. You see how this works? 2x equals 22. That's what this line here says. And since we're making things balanced and equal, 1x has to be 11. Okay, so because we're awesome, we would finish this problem by saying Dr. Ramirez saw 11 patients in the morning and to answer part B, how many in the afternoon? The afternoon was x plus 4, so 11 plus 4 is 15. Patients in the afternoon. And just as a little check, notice that 11 plus 15 does equal the 26, which we knew it would. All right, so that's word problem slide 33. Okay. Let's jump to slide, let's see, this is slide 38. Everything is outlined on these PowerPoints, and it's a very good idea to have a look at your textbook. I even feel that the textbook might be even, it's more reading. Like if you're finding that this math course is like easy peasy, then these slides are pretty straightforward and quick. If you're finding that the math is just a little bit, you're wondering a little bit, and you need something a bit deeper, and you've got some extra time, I would say that the textbook, reading through the textbook is quite good. Slide 38, it says the sum. Now the word sum means we add up a bunch of stuff. So the sum of 3 consecutive numbers is 177. Find the integers. Okay, the sum. So I've got 3 numbers. This one, plus this one, plus this one. We add them up. We get 177. Okay? So consecutive, in order to solve this problem, you need to know what the word consecutive means. Consecutive means in a row. So if this number is x, then the one that's right after it would be x plus 1. And the one after that one would be x plus 1 plus 1. I'm going to write it as x plus 2. This is how we can write 3 consecutive numbers. Okay? So if I collect like terms now, I've got x plus x plus x. And I've also got 1 plus 2, and that equals 177. My iPad wants to solve all of these for us. I'm just plowing ahead. Sorry for the distraction. All right, so we've solved these a couple of times already. We're going to take away 3 from here and 3 from here. And that gets rid of that. And on the right side, I've got 174. And on the left side, I've got 3x. 3x equals 174. And this means 3 times. And my iPad's telling me I'm running low on power, so I'm going to pause in a moment. Let's divide this by 3, both sides. And we're left with x equals 174 divided by 3. Well, 3 into 17 goes 5 times. I'm going to do long division just to remind you. I'll bring down the 4. 3 into 24 goes 8 times. Woohoo! Nice, with no remainder. So x equals 58. And the question said, find the integers. So we're going to finish off with, therefore, the integers are 58, and they're consecutive. And the next one is x plus 1, so 59 and 60. And that handles that. Now, often, these are straight ahead questions. Oftentimes, on a test setting, you would often say, let x represent the first integer or number. Okay, I'm putting that in at the end. I think on a test we want to see that, but when we're just solving things, sometimes a little diagram, and what I did was I wrote down, x plus 1 plus, like I wrote it down in this way. And sometimes a diagram is good enough. And this is a little bit of a diagram here. I wrote x, another blank, and because it's in the question, that equals 177. So having a let x statement's a good idea, but sometimes you can get away with just setting up the question. So hope that helps. Looking ahead here, there's a question here on slide 40. It's talking about similar kind of idea, the sum of two consecutive even integers. Sum of two consecutive even integers is, and it's a negative, is negative 266. So if I think about that, if you take a number, I just put a box for a minute, and we're going to add another number because it says sum, so we're going to add two numbers, and this is going to be equal to negative 266. So these are both going to be negative numbers, okay? And let's talk about even numbers. One of those numbers would be, if it's even, it means that it's a multiple of 2, like 2, 4, 6, 8, 10, 12, 14, 16, and so on. So I'm going to call that number 2x. Okay, because that guarantees, if you think about any value of x and you multiply it by 2, you're going to end up with an even number. So here's a case where I'm going to just make a statement. Let x represent an integer. Okay, and then the first of the two consecutives is going to be 2x. The next one, it's not going to be 2x plus 1, because if you take an even number and add 1, you get an odd number. So the next one would have to be the 2x plus 2. Okay, because if you take two even numbers like 4 and 6, or 12 and 14, or negative 28 and negative 26, they're different by 2. Okay, so that's what this one is about. It's a little bit trickier than the last one, but we can handle it. 2x plus 2x, that's 4x, plus 2 equals negative 266. No problem. Negative numbers don't scare us. 4x equals. Now, what I've done for other ones, and we're going to do again, is this plus 2. We're going to go minus 2 and get rid of it. We're going to take minus 2 off of this one as well, on both sides. So minus 266 minus 2 is minus 268. All right, and now we'll divide both sides by 4. And, excuse me, but we'll be left with a negative number, and 26 fours into 260, or into 26, goes 6 times. 4 times 6 is 24, with 2 remainder and 7. Now, one of the answers, so we've got x equals 67. We're kind of like doing pretty well here. But the first number that we're most interested in is 2x. Okay, so now we're just going to say first number is 2x, which equals 2 times negative 67. Okay, and that is equal to negative 134. Okay, 120 plus 14. Second number is 2x plus 2. We already know what 2x is. It's negative 134. Plus 2 is negative 132. Ran off the page there. So the two numbers are negative 134 and negative 132. And when you add those together, those two numbers, you will get negative 266. Nailed it. There we go. Now my iPad is almost out of juice, so I'm going to turn it off for a bit and charge up, and I'll come back with a few closing remarks, and then we'll be off for the reading week. Anyway, talk to you in a minute. Okay, so we're just about at the end here. Little bit of follow-up to today's class on Wednesday's class, excuse me. So say we have a cylinder, and the volume is the formula for volume is given here, pi r squared. That's the base. That's the circle on the bottom, times the height. And if we're given the volume of 75.4 and a radius of 2, then the question is, what is the height? Okay, that's what we're going to work with here. So we can substitute into our formula. So let's go 75.4 equals pi times r squared times h. So this is an equation, and it has a variable in it. You see the variable is h, and it's an equation because I've got an equal sign. So just working out a couple things here, we can say 2 squared is 4, so that's 4 pi times h. And once again, similar to our other bits, we have 4 times pi times h. And the pi is a fancy symbol there, but it's also just a number. So we're going to divide both sides by pi. Excuse me, by 4 pi. And that's the nice thing about that is the 4 pi's divide out, and our final answer is h equals 75.4 divided by 4 pi. Now, if you were going to do that on a calculator, then you really should work out the 4 pi first, or at least, get a handle on that, because we want to do 75.4 divided by all of the 4 pi, not just 4 and then pi. So a few tips on the calculator here. The way to type it in. One is 75.4 divided by bracket 4 pi. Okay, that'd be one option. Another one would be 75.4 divided by 4, and get that answer, and then divide again by pi. Okay, or, so that's two options. I'm going to give you a third one. So this is first option. Second option. Third option would be take 4 and times by pi and get an answer. Okay, and then we're going to store that in A. This was using our memories on our calculators. And then once you've finished that, you could type 75.4, and then you would divide by the value of A. And the way that you get that is to push the recall button on your calculator and A once again, and that's another way to do it. If you're using your iPhone or a phone of any kind, you can always hold on your screen to do a copy and then a paste. So I'm just going to work this one out here on my computer. 75.4. Oh boy, hang on one second. 75.4 divided by 4 pi, and that is equal to 6 0.0 rounded to 1 decimal place. It's 0.00014,135, but to 1 decimal place is 6.0, and the units on this would be inches. Okay, so that sort of wraps up solving an algebraic equation, and it also wraps up this lesson. So I'm going to wish you have a great weekend, or a great week, actually, and I hope that you get some rest and some relaxation, some recreation. I hope that you're safe and that you have a good time, but also that you're able to keep up with your chemistry and your physics and so on. Don't forget that your assignment, it's been extended, so it's due on Tuesday, midnight, or 11:59. Okay, and you can submit twice, up to twice, and you've got 3 days if you need to. Anyway, I wish you well. Thanks for watching all the way to the end of the video, and we'll see you when we get back. Take care. Bye-bye.